Welcome, students. We are in lesson 71. We're going to talk about ellipses finally. So the ellipse is, it's in the circle family in that it has circumference and there is, that whole curvy bit going on. So one of the things that's important to know about the ellipse is that the sum of the distance, first of all, it has what's called foci. And those are 2 points on either side of the ellipse, and I'll tell you how to find those later. But the sum of the distance from each foci in the same ellipse, so either one of these foci, to any point on its circumference, when you add these two distances together, it doesn't matter. The distance from here to here and here to here, that distance and that distance is going, when added together, is going to be the same as this distance and this distance added together. So that is one of the qualities or one of the properties of an ellipse that you can use to find a distance that's missing. If you know what the sum of this distance is, the black distance 1 and distance 2 added together is, then if you're missing one of these distances, then you can write a formula for it to find the unknown value. Because we know that these two, this line and this line, is going to equal the sum of those are going to equal the sum of these. So that's a property that we're going to use in our calculations. Now, an ellipse has two major axes. The circle has a diameter, which is kind of like an axis, but it is the same all the way around, all 360 degrees. An ellipse has two different axes, and I don't know what I just did. Okay, let me get rid of that. An ellipse has two axes, and the major axis is going to be the greatest distance from end to end of the ellipse, and it cuts the ellipse in half horizontally. I guess it could be vertically, but it cuts it in half long ways, exactly in half. And then there is a minor ellipse, and the minor ellipse is the shortest distance from side to side, and it cuts the ellipse exactly in half short ways. So you can find the half of the, like if you're finding the area of half an ellipse, you need to know which way you're going and which one you're looking at. So the major is the longest one from end to end, and the minor is going to be the shortest one. Typically from top to bottom, or what we consider side to side, it's just going to be the shortest ellipse or the shortest axis that cuts the ellipse in half. Now, the standard formula for an ellipse is going to be x squared over a squared plus y squared over b squared equal to 1, or it could also be x squared over b squared plus y squared over a squared equal to 1. So let us find how to use these doing a practice problem. We're going to use this to figure out how to graph an ellipse. All right, so here we have 71.1, and we're asked to graph the ellipse x squared over 25 plus y squared over 9 is equal to 1. So we see that first we set x equal to 0 in order to solve for y. So if we have a 0 of 25, then that just goes away entirely. And then that leaves us with y squared over 9 is equal to 1. We multiply both sides by 9. We get y squared is equal to 9. So when we unsquare 9, we'd get plus or minus 3. And we know a length can never be negative, so it's always going to be the positive number when we talk about length. So y is equal to 3. So when x is 0, y is 3. So I graphed that point right here. Now I know on an ellipse that the height of the ellipse here is going to be the same as the ellipse here, right? It's going to also be, this is half of the ellipse. And this is an ellipse with an origin of 0. So I go 3 down and I get 0, -3 as the other side of the minor axis. So those would be my 2 points. I would have 0, 3 and 0, -3. So you have to account for the other side of the ellipse as well. All right, that's how you would do it. And then we set y equal to 0 to find the value of x. That would go away, leaving x squared over 25. Multiply both sides by 25. X squared is 25. X equals plus or minus 5. We know length is always positive, so x is 5. So that means 5 and 0. So 5 and 0 is this point right here. So I also know that the other end of the ellipse has to be accounted for, and that would be -5 and 0. And so knowing those 4 points gives me the opportunity to draw an ellipse connecting all 4 of them. And that is how you would graph an ellipse. All right, there is another way. Let's look at the next practice problem. So here we're asked to graph an ellipse, and we have 5x, I'm sorry, I didn't write that right. It should be plus 2y squared. 5x squared plus 2y squared equals 15. Well, we know this has to be set equal to 1. So we're going to divide everything by 15 in order to make this 1. So 5x squared plus 2y squared equals 15. Divide everything by 15 so that this now becomes 1. So we have 5x squared over 15 plus 2y squared over 15 is equal to 1. Right, so that's how we eliminated the 15 here. Now we're going to simplify if you can. So 5 over 15, we want to make sure we have no coefficient with our x. So it'd be x over 3, x squared over 3. Because we can divide both of these by 5, and that's what we get. That leaves us a 1 coefficient with our x squared. Now we're going to divide, we're going to look at this. We're going to divide both of these by 2 in order to get rid of the coefficient with y. So 2 divided by 2 is 1, so it leaves me y squared here, and 15 divided by 2 is 7.5. So from here, I know that x squared is going to be equal to 3, and y squared is going to be equal to 7.5. So if x squared is equal to 3 and y squared is equal to 7.5, then x is equal to plus or minus, which we know it's plus, the square root of 3, and y is going to be equal to plus or minus the square root of 7.5. So the distance is square root of 3, and the distance is square root of 7.5, but you have the positive side and the negative side for the x, and the positive side and the negative side for the y. So let's see if we can figure out what those are. All you really have to do is put that in the calculator and put in 3, and the square root of that is going to be 1.73. So we're going to have a positive and a negative. So x is going to be 1.73 positive and negative 1.73 when y is 0. And the y is, when x is 0, the y is going to be equal to, let's find it, we have 7.5, and that is squared, that's going to be 2.74. So it'll be a positive, I don't know why I put the plus sign, I never put the plus sign for positive, and then all of a sudden I decided to do it. 2.74 here and a negative 2.74 here. And those are your points to graph for y. So again, it's the same process that we did for 71.1. We just had to kind of rearrange it a little bit and solve to get there. All right, so this is the way you want to look at your problem. Whatever the number is below that value or below that variable, you can set that equal to the variable and then find the square root of that number, and that's going to be your 2 points, positive and negative. So here we have, oh goodness, how am I going to do 1.7? I'll get close. How about that? So when y is 0, x is positive 1 and about 3/4, and then negative 1 and about 3/4. And then when y is 0, I have 2.74 and negative 2.74. So that would be our ellipse. Let me see if I can adjust that just a bit and move it right on top of those. So pretty close, pretty close. But what I would want you to do is plot your points, and I'll check your points and then just kind of get close with your ellipse. I know it's hard to draw on the Jupyter system. That's okay, but that's how you would draw it with the graph. You'd get your upper and lower and your left and right points, and then you would graph according to that. But this is how you would find those points down here. And that is, did I do that right? I did that completely wrong, y'all. Look at that. I did it completely wrong. Okay, so how did Miss Tracy do it wrong? Because I did it backwards. It should be y. Y is 0. Did I do that right? Zero is x, y is 2.74, so that should be here and here. I completely did that wrong. And then x is 1.73 and 1.73. So your ellipse should actually be right here. Not where I had it. I read my x and my y the wrong way. You would think I know better than that by now, but you know what? Everybody makes a mistake. So double check, make sure you're graphing it the right direction. You were probably watching me going, Miss Tracy, that's not right. That's not right. It's okay. Everybody makes mistakes. Just double check it before you turn it in. So yeah, these are the points, and the points are right. Miss Tracy just graphed it wrong. So pay attention to your X and your Y. Label it if you have to make sure you do it right. Okay. It's probably because it's after 9. You know, I'm old. I have an early bedtime. So that's probably what it was. But anyway, those are the ways that you can transform an equation to find your points. And then that's how to find your points. Understand that you're just going to take whatever this is. When this is equal to 1, you take whatever this is and turn it into that and get your plus or minus and create your points here when y is 0. And whatever this one is, you want, if this is y, you want to set x equal to 0 and do the same thing with it. Set it equal to what the denominator, find the plus or minus, and then that is going to give you your points for the y-axis where you need to put those points. And we will talk about translation of the ellipse at a later date. That's all we're doing for right now, is understanding how to find the points to graph an ellipse. And we'll talk about the foci later. That's all I have for lesson 71. I will see you in lesson 72.